So now guys, what we're going to do is we're going to now get into the nomenclature. So basically what we learned previously is going to help us for nomenclature as well. But now let's actually get into nomenclature. Nomenclature basically means guys, naming, okay? So nomenclature, this is inorganic nomenclature, guys. At the end of the semester, we're also going to learn organic nomenclature. Organic nomenclature is when you have carbons as the main part, the main skeletal of the molecule. Inorganic is everything else. So right now, we're going to cover inorganic nomenclature. Inorganic nomenclature, guys, are molecules or compounds are basically divided into three different categories. So the first category, guys, the first two categories we already know. We know that our compounds, so I'm going to say compounds. We already know compounds are two types. Compounds can be ionic or they can be covalent. So those are our first two types, ionic and covalent. Can you tell me, guys, what is another name for covalent? Yes, they're also called molecular compounds. Now, the third one that we're seeing here, guys, are called acids. Okay, we're going to talk about that as well. So ionic, guys, how do you recognize if something is ionic or not? Ask yourself, how do you tell, guys, if something is ionic or not? If you're made up of a metal and a non-metal, then you're ionic. If you're made up of a non-metal and non-metal, then you're molecular or covalent. When you have hydrogen on a negative ion, then that is an acid, okay? So let's quickly take some examples. NaCl is example of ionic compound, metal and non-metal. Covalent or NaCl, example is CO2, you got a non-metal and a non-metal. For acids, HCl, you see Cl is negatively charged and H we know is positive, but we got hydrogen sitting on a non-metal. HCl is an example of an acid. There are more examples like H2SO4, which you might have heard of, which is sulfuric acid. HCl is hydrochloric acid. So by the end of this lecture, you should be actually able to name them. That's the goal, okay? So now, guys, these are our three main categories. We know how to recognize molecules and you put them into the right category. So for all these three different categories, guys, what we're gonna do is we're gonna learn how to name them because there are different rules for naming them. First, let's talk about what you already know, because what you already know, you basically know the names. You basically have to just realize yourself with what you know, and you will be able to then know or remember the rules. Okay, like NaCl is called sodium chloride. So if you ask yourself, what have you done here in naming this? Na is called sodium. You just put it as it is in the name. Cl, guys, Cl actual name is what? See, when I say Cl, if I see Cl on the periodic table like here, this is called chlorine, okay? This is called chlorine. But when you have Cl as the nonmetal, the second atom in a compound, you change the suffix to IDE. Guys, IDE is the suffix you use here. So the suffix you use for the non-metal, or basically the second atom or element of the compound, you use the suffix IDE. Okay, so what you basically do is you don't call this sodium chlorine, you call this sodium chloride. Okay, now what do you do for this guy? You all know that this thing is called carbon dioxide. Now, do you notice that C, carbon is as it is, oxygen, you change to oxide. So same thing that we did here, you added IDE. But there's one more thing that you're doing here, which you usually don't do in ionic compounds. So if I give you the example of CaCl2, this is also called just calcium chloride. But when you come here, you do not just call this carbon oxide. You call this carbon dioxide, and di is there to tell you that you have two oxygens. Di means two, and you got two oxygens. Whereas here in calcium chloride, You never said calcium dichloride, and it'll be wrong if you say calcium dichloride on the exam. Okay, so CaCl2 is calcium chloride, NaCl is also sodium chloride. So you never use these prefixes. So the prefixes are only used for molecular or covalent compounds. Never ever use a prefix for ionic compound. And why is that? See, when I see that my name is calcium chloride, what I'm gonna do, guys, when I'm trying to name this, what I'll do, when I'm trying to put the formula, so guys, this CaCl2 is the formula. This is called formula, and this is called the name. So when you have things in the word, that's a name, and this is the formula. So let's say we don't know the formula, okay? So let me erase this. Let's look at the name and see if based off this name, I can go back to that formula of CaCl2 without using that di prefix here. Let's see if we have sufficient information to do that. And you'll see we actually do. So guys, when you're trying to put the formula for ionic compounds, strictly speaking, you should write down the symbol. For calcium is Ca, for chlorine is Cl, and put the charges. Calcium is +2. How do you know that? I know that because calcium is +2 on the periodic table because it's group number 2. So if we go back, calcium is marked as +2 and Cl is marked as -1. So as you saw earlier, what we did was we did the crisscross. Ca got 1 and Cl got 2. So CaCl2. You see how without writing that di, just because we know the calcium's charge is +2, we were able to get to the formula from the name. But in the case of covalent or molecular compounds, we use the help of prefixes in order to tell how many oxygens we have. Like for example, if I have to write down P2O5, then what are we going to call this guy? So we should know that if you have 2, we call that di. And when you have 5, that's called penta. We're going to make a list of this and we'll learn. So this is called diphosphorus pentoxide. So you see how we are using the prefixes when it comes to molecular or covalent compounds, but when it comes to ionic compounds, we never use prefixes, guys. Please keep that in mind, never use a prefix. Now, talking about the acids, we'll come to the nomenclature of the acids later on when we will talk about, when we'll finish ionic and covalent compounds, okay? I'll quickly give you the name for this. This thing is called hydrochloric acid. You guys can see how these three are different in their names. This one, sodium chloride, carbon dioxide, prefixes, no prefix. Yes for the prefix. Here, you have the word hydro in the front, and in the end, you have ic acid. And guys, H2SO4 is named a little differently. This guy is only called sulfuric acid. And you're going to say, where did that hydro go? Guys, H2SO4 is a little different from HCl. Why? Because this does not have oxygen. This one has an oxygen, guys. When you see when there is oxygen, the word hydro is missing. You do not put the word hydro in the front. You just leave that out. The rest is same. Like you see chloric acid, this is sulfuric acid because it's made up of sulfur, so sulfuric acid. Again, we'll come back to that nomenclature in more detail.